Hello everybody, this is Mr. Kusaj, and we're up to lesson 4-2. This is degrees and radians. Don't forget to put your date up there. First, before we get to degrees and radians, first of all, degrees is talking about angles, right? You remember angles, we measure them in degrees, where there's another way of measuring them in radians, and we'll talk about that in this section. First of all, let's go back to just talking about angles. When you look at an angle, how do we measure it? Well, you have the angle, and usually you start on one side and you open up in a circular manner, right? And where you stop, you form an angle. So you have a starting side and an ending side. We call that initial side and terminal side, okay? And if we were to put that on a grid, a coordinate plane, right, we would start here on the x-axis and then go all the way around, okay? So we call that standard position when you start here. That's called standard position, all right? So just keep that in mind when we see that word standard position. The other thing you need to know is, depending on which direction you go, it's either positive or negative. When we turn this way, which is counterclockwise, that's the positive direction, right? So when we open up this way, right, that would be a positive angle. When we open up this way, right, clockwise, that would be negative. So how would you know, like for this angle, how would you know if it's positive or negative? Well, it would either be written down somewhere, or you'd have these little arrows, right? So if the arrow was here, then we're talking about the positive angle. If the arrow was going this way, like this one, we'd have the negative arrow. So anyway, opening clockwise is the negative angle. The other thing you need to know is the common angles, right? So remember, angles are parts of circles. So really quickly, I know it looks like a lot, but if you look closer, by common angles, we're really talking about the special angles, okay? Special angles because they're easier to work with, and we already know the answers. Remember when we did the special triangles, 30, 60, 45? This is it. So, you know this one. If we start at 0, this would be 30, 45, 60, and then 90. But if we can do 36, 45, if we can do 30, 45, 60, then we can do those angles in the other quadrants also. So if we go from here, if we take the same angles that have these numbers, right? You can see that this is 30, 150 to 180. You can see this is 45, and this is 60, 120 to 180. So these are special because they have the same, well, we'll talk about it later again, but the same properties and answers with very little difference than these. So all of these are special angles because they're multiples of really 30, 45, and 60. And these are special because they're right on the axes. If we put this on a standard position, right, these would be right on the axes. So they're going to be special. Okay, so these are common angles that you're going to see throughout the whole chapter. All right? Next, DMS stands for, hold on, DMS stands for degrees, minutes, seconds, and decimal form. So think about the clock for a second. If somebody says, oh, it took me 1 hour, 1.5 hours, 1.5 hours to do something, well, another way of writing that would be in hours and minutes. So in hours and minutes, that would be 1 hour, 30 minutes. Not 50 minutes, not 5 minutes, 30 minutes. So how do you go from one to the other? You want me to give you another one? What if you said 1 hour and 15 minutes? What would that be as a decimal? Well, you're supposed to know this is a quarter of an hour, so it's 1.25 hours, right? I went from hours and minutes. By the way, there's no seconds here, but you could do it with seconds too, to decimals. So that's what this is. Degrees have minutes and seconds too. You have whole degrees, like hours, and then you have minutes and seconds. And we want to be able to change them back and forth from decimal to minutes and seconds. Good news, everybody. The calculator does that for you. So 1 degree, just like 1 hour, 1 degree is 60 minutes, and 1 minute is 60 seconds. Just like time, just like the hours. So for example, 12 degrees 30 minutes is the same as 12.5 degrees, right? 12 and a half degrees, half a degree is, right? Half a degree is 30 minutes. Like a half hour is 30 minutes. So how do we go back and forth? Calculator. If you look at, well, our calculator, if you look at the calculator, there is a button, a function that says angle on it. Go there and you will see DMS. You will see that. So look for these symbols, right? This symbol stands for degrees. One little line like that is minutes and seconds. So you would have numbers here. Something degrees, something minutes, something seconds. Okay, that's what you're looking for in the calculator. That's degrees, minutes, and seconds. And you already know what decimals look like. So for example, if you enter this in the calculator, press equal, and it'll give you the decimal. So that was DMS, right, degrees, minutes, seconds, to decimal. And if you enter this, the decimal, and push the right button in reverse, right, it'll give you degrees, minutes, and second. Again, we'll do this in class. We'll practice it in class, but you can go from DMS to decimals with the calculator. Okay? Decimal to DMS is the second one. Okay. Now, this is the biggie. Radians. This is also in the calculator. Radians, rad for short, rad for short, is another way to measure angles. Okay? Think of it like a second language, right? You know what 90 degrees mean. But 90 degrees is in degrees, and in radians it has a totally different number. It's like a different language. All right? Kind of like going from miles to kilometers or meters to yards. You're just switching over to another language or another system. Okay? And I'll show you how to do that. So now you know in degrees, one circle is 360. Right? Well, in radians, one circle is 2 pi. In fact, I should have written here radians, right? This is degrees, 360. But if we're speaking the radian language, it's 2 pi. Okay? I know it looks funny, but bear with me, and you'll catch on. So if you look at these simple angles, right? This is full circle, so that's 360. This is half circle, 180, and this is 90, right? So in terms of radians, this would be 2 pi. This would be half of 2 pi. Think for a second. Half of 2 pi is 1 pi, right? This would be a quarter of a circle, which is a quarter of 2 pi. Okay? Since this is pi, isn't this half of pi? Right? A quarter of 2, isn't it half? Okay, let's not get too deep into this. Just know that full circle is 2 pi, half circle is pi. Half circle is pi, so that must be half pi. And you can write it half pi or pi over 2, that means the same thing. All right, so you already know 3 angles in the radian language. Okay? Let's talk about how, in general, how to switch back and forth. Okay? So converting from degrees to radians or from radians to degrees. Well, some of the easy ones you should memorize, like the three we just did, right? Full circle is 2 pi, half circle is pi, and 90 degrees is pi over 2. So you should memorize those. But if you don't memorize them and you want to do any one of them, what you do is, to go from degrees to radians, is take your degrees and multiply by pi over 180. Okay? So let's do it an easy one. 360, you take that and you multiply by pi over 180, and the answer will be radians. So what is that? 360 over 180 is 2 pi. So 360 degrees is 2 pi. Did that one. That's what you do for any angle. Okay, what about going the other way? What about going from radians to degrees? Okay, then you multiply not by pi over 180, but 180 over pi. Okay, and here's how I remember which to multiply with. Here, I want the answer with pi, so the pi is on top of 180. Here, I want the answer in degrees, so the degrees is on top of pi. Right? Pi has to do with radians. I want radians, so put the radians on top. I want degrees, so put the degrees on top. So let's see if it works. Well, remember what pi was? Pi was 180 degrees. Well, let's pretend we don't know that. So I want to change this to degrees. So I multiply by 180 over pi. And look what happens. The pi's cancel, and boom, it's 180. That works for any degree you want. So how about 45? 45 degrees is, in radians, 45 times pi over 180, and then 45 over 180 reduces to 5 over 20, and that reduces to 1 over 4. Oh, it's pi over 4. 45 degrees is pi over 4, 1/4 pi, or pi over 4 radians. I changed degrees to radians. How about this one? I have pi over 6. What is that in degrees? Well, I multiply by 180 over pi. The pi's cancel. And 180 over 6 is 18 over 6, which is 3, with a 0 next to it. 180 over 6 is 30. So pi over 6 is really 30 degrees. Right? So all you're doing to convert back and forth is either multiplying by pi over 180 or 180 over pi, depending on which direction you're going. Okay. This is important too. Well, everything is important. Everything is important, otherwise I wouldn't be writing it down. Okay, taking too much time. Let's get to the notes. Coterminal angles. That's a symbol for angles. I don't want to write the word angles all the time. Coterminal angles. That's an angle plus a full circle. Let's think about this for a second. If you have an angle, let's think for a second. If you have an angle, here's an angle, right? You open up to here, right? And you end up right there. Well, if you go full circle, one full circle, don't you end up exactly at the same spot? You do. What if you go another one? So as long as you go more circles, you're going to end up in the same position. So if you start with, say, 10 degrees, then that's 10 plus 360, that's 370. 10, 370. Why? They end up in the same place. Another 360, that's, I don't know, 600, 730, right? So all of these are coterminal. Why? Because they end up at 10. Okay? So this is how I tried to do it in the notes. So that's 10, right? Then if you go around again, that's going to, wait. That's going to be 10 plus 360, which is 370. So those are the same angles, but one went around a full circle. The same coterminal, right? What that means is they end at the same place. And you can keep doing this, right? 10 plus 2 full circles. And you have another angle at the same place. 10 plus 3 circles will be in the same place. 10 plus 100 circles will be in the same place. On and on and on. They will all be coterminal. They'll all end up in the same place. Almost done. Almost done. Oh, part 1 anyway. You can also go backwards, right? You can go full circle backwards. So minus 360, right? So here's 10. Go backwards full circle. So that would be 10 minus 360 is negative 350. So check this out. This angle here is 10, 370, 730, negative 350, and if you do one more backwards, negative 710, because it's 10 minus 2 circles. Okay? I know I said a lot, but that's because there's many examples here, but all we're doing is going full circle one way or the other and adding or subtracting 360. And we get a new angle, but it's at the same place, the same position, coterminal. They share the same position. Okay? Okay. So let me leave you for part 1. Let me leave you with some try problems. Okay, so when I see you in class, write in DMS. So here's a decimal, change it to DMS. Write this as a decimal. It's DMS now, write it as a decimal. Oops, that's the answer. Right, so this is write in radians. So this is degrees, write it in radians. I know you saw the answer, but try to do it without looking. And this is radians, try to write it in degrees. Remember, it's either times pi over 180 or times 180 over pi, one or the other. And then here, we have identify all the coterminal angles and draw. That's what I did before with the full circle, full circle, full circle. So if you start with 43, go another 360, another 360, another 360. If you start, oh, this is radians. Oh, look at that. So here, you don't add 360. What do you add? What is a circle in radians? 2 pi. So here, okay, we'll do this in class. Here, you do plus 2 pi, plus 2 pi, plus 2 pi to get all the coterminal angles, right? Okay. See you in part 2. 18 minutes, that's not too bad. All right, bye.